Hello friends, continuing with Gauss law, today we take up significance of Gauss law. Gauss law is a fundamental law and its equation is displayed as one of the four Maxwell's equations of electrodynamics and electromagnetism, which can solve all problems of electrodynamics and electromagnetism. I repeat, Gauss law is a fundamental law and its equation is displayed as one of the four Maxwell's equations of electrodynamics and electromagnetism, which can solve all problems of electrodynamics and electromagnetism. These four Maxwell's equations are: number 1, surface integral of electric field over closed surface is equal to 1 by epsilon 0 times the charge enclosed, and it is known as Gauss law of electrostatics. Number 2, surface integral of magnetic field over closed surface is equal to 0 always, and this is Gauss law of magnetism. Number 3, line integral of electric field between 2 points A and B is equal to minus d phi E by dt, and it is Faraday's law of electromagnetic induction. Fourth equation is line integral of magnetic field over closed loop is equal to mu 0 times the conduction current plus displacement current, and it is modified Ampere's circuital law. These are four Maxwell's equations and Gauss law is one of them. Now, Coulomb's law is not a fundamental law, it is intrinsic to Gauss law. I repeat, Coulomb's law is not a fundamental law, it is intrinsic to Gauss law. So, Gauss law is a fundamental law and can be used to find electric field intensity due to a point electric charge as well as charge distributions, whereas Coulomb's law is applicable only to point electric charges. I repeat, Gauss law is a fundamental law and can be used to find electric field intensity due to a point electric charge as well as charge distributions, whereas Coulomb's law is applicable only to point electric charges. Now, 7 steps to find electric field intensity using Gauss law. If you remember these 7 steps, you will be able to apply Gauss law for finding electric field intensity due to a point electric charge or due to a charge distributions. These 7 steps are: A, identify charge enclosed. B, identify point where electric field is to be determined. C, identify Gaussian surface. D, calculate charge enclosed by Gaussian surface. E, calculate electric flux linked with Gaussian surface. F, use Gauss law. G, calculate electric field intensity. So, following these 7 steps, you will be able to use Gauss law for finding electric field intensity due to a point electric charge as well as due to charge distributions, that we are going to do in near future. In the coming up lectures, we will be applying it to find out electric field intensity. Okay, so this is the order, you must have to remember it, and this order must not be changed. This order is set to deal with electric field intensity using Gauss law. Okay. Now, derivation of Coulomb's law from Gauss law. Coulomb's law can be derived from Gauss law in 2 steps. First step is calculation of electric field due to point electric charge at a distance r from it, and second step is Derivation of Coulomb's law using equation F is equal to QE. We take up one by one. We take up first step, calculation of electric field intensity due to a point electric charge at a distance r from it. So let us follow the 7 steps. First step is identify charge. So we identify charge. Consider an isolated point electric charge plus Q lying in any region of space as shown. B. Identify point in region. Let P be any point at a distance r from the charge where electric field intensity is to be calculated. C. Identify Gaussian surface. Assume a closed hypothetical surface in the form of sphere of radius r around the charge with its center at the charge q, such that point P lies on its surface as shown in diagram. D. Calculate charge enclosed. The charge enclosed by Gaussian surface is equal to Q. E. Calculate electric flux linked. Now, due to symmetry, electric field intensity at every point on the Gaussian surface would be same as E equal to K naught Q by R square along radius directed outward. Therefore, electric flux linked with whole Gaussian surface would be, say, phi E equal to E dot S, or it is equal to E mod S mod cos theta. But theta between area vector S and field vector E is 0 because electric field vector and area vector both are directed along radius directed outward. Therefore, flux linked with Gaussian surface is equal to E into S or E into A, or it is equal to E into 4 pi R squares. Let us mark it as equation 1. F. Use Gauss law. Phi E is equal to 1 by epsilon 0 into QEN, that is charge enclosed. Substituting the value of phi E equal to E into 4 pi R square, we get E into 4 pi R square is equal to 1 by epsilon 0 times QEN, that is charge enclosed. G. Calculate electric field intensity. From above equation, we have E is equal to 1 by 4 pi R square into QEN divided by epsilon naught, or it is equal to 1 by 4 pi epsilon naught QEN divided by R square, or it is equal to K naught QEN by R square, where K naught is equal to 1 by 4 pi epsilon naught, or E is equal to K naught QN by R square. Mark it as equation 2, and this field is along radius directed outward. Now, second step, derivation of Coulomb's law using equation F is equal to QE. If we place a test charge Q naught at the point P, it will experience a force F is equal to Q naught E. Let us mark it as equation 3. Substituting the value of E from equation 2 in equation 3, we get F equal to Q naught K naught QEN divided by R square, or it is equal to K naught QEN divided by R square, or F is equal to K naught QEN by R square, which is Coulomb's law. Hence, Coulomb's law is intrinsic to Gauss law, that is hidden into it and can be derived from Gauss law. Assignment 1.5 continued. Question number 14. Explain the significance of Gauss law. Question number 15. State 4 Maxwell's equations. Question number 16. Derive an expression for electric field intensity due to a point charge at any point distant r from it using Gauss law. Hence show that Coulomb's law is built into it. Answer these questions on the basis of the text you have learned. Thank you so much. God bless you.